Ever really wondered how Bitcoin actually works? I mean, under the hood. Forget all the talk about digital gold mining for a second. Today, we're going to build our own digital currency right from scratch, just to see what the computers are really doing. Okay, let's get right into it.
So here's the single most important idea you need to get your head around. Having a Bitcoin doesn't mean you have some kind of digital file on your computer. Not at all. It just means your name and how much you have are written down in a very, very special kind of public history book. This isn't money like a dollar bill. It's a shared, unchangeable record of every single transaction that has ever happened. The history is the currency.
All right, let's invent our own currency. Let's play a game. Imagine you and your friends are just tired of swapping cash for every little thing. Coffee, lunch, movie tickets. So what if you just started a shared notebook, a communal ledger, to keep track of who owes who what? A really simple system of digital IOUs.
And look how simple this is. Anyone can just go to this shared file and add a new line. Alice pays Bob $20. Bob pays Charlie $40. Easy. At the end of the month, you all just get together, look at the list, and pay what you owe in cash. Seems perfect, right? But this super simple system has a huge, massive flaw.
Yeah, here's the giant problem. If anyone can just add a line to this notebook, what's to stop Bob from sneakily adding a new line that says, Alice pays Bob $100, when Alice never agreed to that? How can you possibly trust that any of these entries are real?
Well, the solution comes from this beautiful field of mathematics called cryptography. To stop forgeries, every single transaction needs a signature, but not just any old scribble. It needs a special, unforgeable digital signature. And this just perfectly shows the difference. Your handwritten signature, it looks pretty much the same on every check, which makes it, pretty easy to copy. A digital signature is a whole different beast. It's made using your secret private key. Think of it like a password that only you know, and it is completely unique for every single transaction. Trying to copy-paste it is like trying to use your house key to start your car. It's not going to work. So here's the crucial takeaway. A digital signature is basically mathematical proof. It proves two things at the exact same time. One, that the message came from you and only you, and two, that the message itself, like Alice pays Bob $20, hasn't been changed or tampered with one bit.
So just how secure is this? Well, the number of possible private keys is 2 to the power of 256. This number it's just insane. To call it astronomically large is honestly an insult to astronomy. It's bigger than the estimated number of atoms in the entire known universe. So guessing someone's private key isn't just hard, it is physically impossible. Okay, so problem 1 is solved. No more forgeries. Awesome. But a new, even trickier problem pops up. With physical cash, you can't spend the same $20 bill in 2 different stores. But with digital money, what stops somebody from just copy-pasting it and sending the same digital dollar to 2 different people at the same time? This is the famous double spending problem. Just think about it for a second. Since everyone in our group has their own copy of the notebook, network delays might mean Bob sees his payment come through first. But at the same time, Charlie sees his payment come through first on his copy. So who's right? Without a central bank sitting in the middle to say this one came first, you've got total chaos. Both Bob and Charlie could ship their products thinking they got paid, but Alice only ever had the money for one of them. And this right here is the absolute heart of Bitcoin's genius. The solution is to create a system where everyone can agree on the official order of transactions without needing a bank or any central authority. And the way we do it is by making it so people have to prove they've done a whole bunch of really hard computer work. We're going to build a chain of trust using math. Now, to do this, we need a cool little tool called a cryptographic hash function. My favorite way to think about this is like a digital meat grinder. You can throw anything into it, a text message, the entire novel of Moby Dick, a picture, and it spits out a unique, fixed-length digital fingerprint. But here's the magic trick. It's a one-way street. You can't look at the sausage and figure out what cow it came from. It's impossible to reverse engineer. So here's the game. To decide which transactions get to be next in the official history book, we hold a kind of mathematical lottery. Everyone who wants to play grabs a bunch of pending transactions and starts trying to solve a really specific math puzzle connected to them. And it's a puzzle that you can only solve by guessing over and over and over again incredibly fast. So let's see how this all gets built. First, a bunch of transactions are bundled together into something called a block. Next, and this part is absolutely crucial, that new block includes the hash, or the digital fingerprint of the block that came right before it, literally chaining them together. Then, these people called miners all over the world race to solve that lottery puzzle. The first one to find the winning number wins. They get to broadcast their new block to the whole network. Finally, everyone else checks their work, and that block gets locked into place as the next link in this unbreakable chain of history. Okay, but let's just pause for a second here. This is a pretty wild idea, right? We've replaced our trust in human institutions like banks, which we know can be flawed, with trust in pure, cold, hard math and computing power. But let's ask a bit of a contrarian question. Is that really an improvement? Is a system that uses a massive amount of energy just to run a global math lottery fundamentally better than one based on people and laws and regulations? It's definitely something to think about. So, you're probably wondering, why would anyone even bother doing all of this intense computational work? Well, it's because this whole system for validating history is also how new money gets created. The lottery isn't just for putting transactions in order, it's for minting the currency itself. And this brings us right back to that first big idea we started with. The winner of the lottery literally gets to write the next page in our shared history book. And for their hard work in maintaining and securing that history, they get rewarded with brand new currency, created right out of thin air. Miners get paid in two ways. The first is the block reward, which is a set amount of new Bitcoin given to the winner of that lottery. Think of it as the grand prize for all their hard work. The second way is through transaction fees. These are small optional payments you can add to your transaction to give miners an incentive to pick your transaction out of the pile and make sure it gets onto the next page of the book. So look at what we've just done. We started with a simple idea, a shared notebook. We made it secure against fraud with digital signatures. We solved that critical double spending problem with a global math lottery. We linked all the pages together to create an unbreakable chain of history. And in the very process of securing the book, we actually invented the money itself. We just invented Bitcoin. In the end, all money, whether it's a dollar bill or a seashell, it's really just a shared story that we all agree to believe in. It has value because we collectively decide it has value. So the final question is, what new story does this system tell? Well, it's a story about a world with no single ruler, where trust isn't placed in institutions, but in mathematics. It's a new kind of shared belief for a digital age. And that's our deep dive into how Bitcoin really works, from the ground up. If you want to go even deeper, you can find the original source for this analysis linked right in the description of this video. And hey, if you enjoyed this, please be sure to follow, like, and share the podcast, What Bitcoin Taught Me, and follow us on Twitter/X, Nostr, Blue Sky, Threads, Instagram, Facebook, LinkedIn, Spotify, and now YouTube. Thanks for watching.